When you look up at the night sky, you see stars and planets, but the universe hides its biggest secrets. The darkest and most mysterious of all, black holes. These are monsters of gravity, so powerful that nothing, not even light, can escape. Black holes aren't just science fiction, they're real, lurking in the cosmos. What are they? Where do they come from? And what would happen if one got close? Black holes challenge everything we know about physics. Time and space twist at their edges, pushing our understanding to the limit. That's why scientists build incredible tools to study them from afar, using telescopes and listening for gravitational waves. But what if we could create a tiny, safe black hole here on Earth? This isn't just curiosity, it's about unlocking the secrets of the universe's birth, the same forces present at the Big Bang. If we understand black holes, we understand how everything began. This quest led scientists to a special place, CERN. Then came a rumor. Were scientists at CERN trying to make a black hole? The story spread fast, sparking fear and wild imaginations. People worried, could a man-made black hole swallow the Earth? The truth, though, is far more fascinating and much less scary. It's a story about discovery, not danger. So what really happened at CERN? Let's find out. CERN is no ordinary lab. It's a global hub for exploring the universe's tiniest building blocks. Deep underground near Geneva, scientists from around the world unite to study particles smaller than atoms. Their tool? The Large Hadron Collider, or LHC, a 27-kilometer ring buried 100 meters below ground. Inside, powerful magnets accelerate protons to nearly the speed of light, sending them racing in opposite directions. The goal: smash these particles together at incredible energies. When they collide, they briefly recreate conditions from the dawn of the universe. It's like a time machine, letting us glimpse the universe's first moments. Imagine smashing 2 watches to see what's inside. The LHC does this with the building blocks of reality. Giant detectors act as high-speed cameras, capturing the aftermath of each collision. Scientists analyze these snapshots to uncover new particles and test their theories. This is how the famous Higgs boson, the God particle, was discovered. The LHC isn't just about smashing things, it's about piecing together the universe's deepest mysteries. Every collision is a chance to learn something new. The scale, the technology, and the ambition are unmatched. But could this machine really make a black hole? That's the question that captured the world's imagination. Let's dive into the experiment that started it all. What were scientists really hoping to find, and was there ever any real danger? The idea of creating a black hole at CERN sounds wild, but for physicists, it was a scientific possibility worth exploring. Some theories suggested that smashing protons together at high energies could, in rare cases, create a microscopic black hole. This wasn't the main goal, but if extra dimensions of space existed, it might be possible. The experiment wasn't called "Let's Make a Black Hole Day," it was just part of the LHC's search for new physics. If a tiny black hole formed, it would be smaller than a proton and vanish almost instantly. According to Stephen Hawking, such black holes would evaporate in a flash, leaving behind a unique burst of particles. Scientists weren't looking for monsters, they were searching for a specific signature in the data. Finding it would be revolutionary, proving extra dimensions and changing our understanding of gravity. The stakes were high, not for safety, but for science. The world watched as CERN pushed the boundaries of knowledge. Would they find evidence of a microscopic black hole, or would the universe keep its secrets hidden? The experiment was underway, and anticipation was at its peak. But what exactly is a black hole, and why did people fear them? Before we reveal what happened, let's clear up the science behind the scare. What makes black holes so powerful, and so misunderstood? Let's break down the basics. Then we'll see what really happened at CERN, and why the world had nothing to fear. A black hole is a region where gravity is so intense that nothing, not even light, can escape. They form when massive stars run out of fuel and collapse under their own gravity. The core shrinks to a point of infinite density, a singularity, surrounded by an event horizon, the point of no return. Cross it and you're gone forever. That's why they're called black holes. The fear at CERN was that even a tiny black hole could grow, devouring the Earth from within. This idea sparked lawsuits and media panic. But the reality is very different. Black holes in space are born from stars with enormous mass. Any black hole created at the LHC would be unimaginably tiny, made from the energy of 2 protons colliding. According to Hawking, the smaller the black hole, the faster it evaporates. A microscopic black hole would vanish in a burst of energy before it could affect anything. The scientists knew this, but public fear was fueled by misunderstanding. The truth, there was never any real danger. The experiment was about testing bold ideas, not risking the world. So, what happened when the collisions began? Did CERN find the signature of a black hole? Or did the universe have other plans? Let's see what the data revealed. The LHC roared to life, accelerating protons to nearly light speed. In the control room, scientists watched as millions of collisions lit up their screens. Each collision was a tiny fireball, a glimpse into the universe's earliest moments. The detectors captured every detail, and computers sifted through mountains of data. Scientists searched for the telltale burst of particles, a sign of a microscopic black hole. They combed through trillions of collisions, analyzing every possibility. The process was painstaking, the excitement palpable. Months turned into years as the search continued. Along the way, they confirmed the Higgs boson and studied the universe's primordial matter. But the big question remained. Would they find a black hole? The world waited for a dramatic discovery. The results were in. Did CERN create a black hole? Or did the universe keep its greatest secret safe? The answer would surprise everyone. Here's what they found. After years of searching, the verdict was clear. No microscopic black holes were found at CERN. There was no unique burst of particles, no evidence of extra dimensions. The dramatic event some feared and others hoped for never happened. But this wasn't a failure. In science, not finding something is just as important as making a discovery. It means some theories about extra dimensions were likely wrong. Scientists narrowed their focus, moving closer to the truth, and they could reassure the world, the LHC is safe. Nature does this experiment all the time. Cosmic rays hit Earth with far more energy than the LHC can produce. If dangerous black holes could form, the Earth and Moon would have vanished long ago. The real story is about careful science, not reckless risk. The search for black holes at CERN is a perfect example of how science works. Bold ideas, rigorous testing, and honest results. The universe is full of wonders, but it doesn't give up its secrets easily. The journey continues, and every answer leads to new questions. That's the spirit of discovery. Black holes and particle physics are full of mind-bending facts. Fall into a black hole and you'd be stretched into spaghettification, pulled apart by gravity. The LHC is one of the coldest places in the universe, colder than outer space, yet its collisions create temperatures hotter than the center of the sun. Supermassive black holes sit at the center of galaxies. Our Milky Way has a mass of 4 million suns. The largest known black hole, Ton 618, is 66 billion times the mass of our sun. The LHC's detectors produce about a petabyte of data per second, more than 200,000 DVDs every second. Only the most interesting events are saved thanks to a global computing grid. This data challenge helped inspire the creation of the World Wide Web at CERN. The extremes of hot and cold, big and small, all meet in the world of particle physics. Every fact is a window into the universe's wildest mysteries. Science at this scale is both humbling and inspiring. The more we learn, the stranger and more wonderful the universe becomes. And there's always more to discover. That's what makes science so exciting. CERN's search for black holes didn't find what some feared, but it was a triumph for science. We proved the planet is safe from high-energy collisions. We ruled out some wild theories and confirmed others. The LHC is now being upgraded to unlock even more secrets. Scientists will keep searching for dark matter, new particles, and the next big breakthrough. The story of CERN's black hole teaches us the value of curiosity and clear communication. Science moves forward by asking bold questions and following the evidence. The universe is more beautiful and complex than we ever imagined. We shouldn't fear knowledge, we should celebrate it. The next generation will push the boundaries even further. Maybe one day, we'll build colliders on the moon or map the universe with gravitational waves. The quest for understanding is what makes us human. We'll always look up and wonder, and the adventure of discovery will never end. That's a story worth getting excited about.